कुछ कुछ क्वेश्चन को मैं थोड़ा ये कर दे रहा हूँ, ठीक ना, अपने वाले।
Okay, it's live now. Hello everyone. Electronics for you के लाइव डिस्कशन में आपका स्वागत है. And we again welcome Ashwini ji and Suresh sir today with us in this live discussion. Today our topic of discussion is types of navigation system like GPS, GNSS, and NAVIC, SSID based location tracking. So, my first question is, what are the different types of navigation and positioning technology available currently?
So there are different kind of navigation technology are available currently that are based on the satellite. One each all of you have might have used, and all of you might know have each the GPS global positioning system. So it is the navigation system that is developed by the USA, and there are but this is not only navigation technology. It is just one of the common technology that you all of you have used and well known about. But apart from this, there are lots of many other such technology developed by many different countries for their own purpose for the navigation. So another technology that is developed by our own country, India, is the NAVIC, NAVIC. That is stands for the navigation with Indian constellation. So this is navigation technology that is developed by the Indian Institute, Indian Space Research Organization, ISRO. And then the another technology that there are few other technology for the navigation system that are developed by different country. One the system that is called GLONASS. So this is the navigation technology that is developed by the Russia. This is similar to the GPS, what you say in the GPS. So according to the different country net, they have developed their own navigation system that work in their country with more accuracy, and that is more reliable to that country apart from the GPS. And there is another technology that is also available for the navigation is Galileo, Baidu, QZSS, QC Zenith satellites systems. So there are several other these navigation technology that are based on the satellite. And there are few technology that are based on the network based, that is what we call the network positioning system or network based localization or navigation system. So these are the cellular network based navigation system or localization system, which you will get the location data using the cell phone tower, but these are not accurate. If you want to go for the accuracy, then GPS, NAVIC or GLONASS and similar navigation system that are based on the tech satellites are more reliable.
Okay, so how does these technology different from each other, and what is the most commonly used technology in positioning and navigation?
So most of you have might have used, like I've told you that heard might have used and also heard about the GPS technology. It is one of the most common technology that you use in your cell phone or in your most of the daily lives. So there are few other that I have listed out just a minute ago. Then these are for the specialized country. These are developed by the specialized country. So GPS, the global positioning system, it is used by most of the phone application, and most of the phone have, and most of the Uber car have around the globe. But there is another navigation system that is developed by our own country, that is the NAVIC, NAVIC, NAVIC navigation system. So this technology developed by the ISRO, I have told you, and this is for the this is developed by the Indian. So and this is for the India country. So if you compare between the normal GPS and the NAVIC, then for India, for the Indian region, for the Indian perspective, NAVIC is more accurate. It will give you the more accuracy, and it will give you the more reliability than the GPS system. So based on these different navigation system developed by different countries, they are more accurate for their region if you compare to the global positioning system, because this is for the global. It's work on the global region. but some country have developed their own that it work in more accurately. And there are if you use the GPS thing there, then at Egypt Global, so there are certain issue of security for the certain country, and so certain country did not allow the GPS to give you more accurate data. So if you want to get more accurate data in certain country like in India, like in Russia, then GPS it might not be the best choice for your navigation system, but the NAVIC or what I say, the GLONASS is more reliable for those countries. Like for Russia, GLONASS is more reliable. For India, NAVIC is more reliable and more accurate. So GPS is overall, and it might be not. It depend on the country politics between two countries, and the how much that country is allowing to give the data to the GPS for their navigation system. So it depends on the country if you use the GPS one, but if you use for the particular country like India, then the NAVIC system is more reliable. So this is a difference, key difference between different those particular navigation system developed by particular country work well in that particular country, while the global positioning system might not work in other country because of the security reason. They might not allow you to give the accurate satellite data. Like you might have seen the Google Street Maps, where in the map you will see the street view of the live street view using the satellite image. But in India, if you see the street view of the satellite image live, it will not give you the accurate and high definition image, because India didn't allow the US to take that data. So it's depend on the politics between the different country as well when you use the NAVIC and the global positioning system.
Mhm. Okay, so first talking about GPS only. So how does a GPS find out where you are, and what parts are needed for it to work?
GPS global positioning system determines your location using a network of the state lines during the using the network of a satellite with that orbit the Earth. Now the question arises how it works and what are the parts needed for its functioning. GPS finds your location with various factors such as the satellite in orbit. These are the at least 20 GPS satellites in the orbit around the Earth at an altitude of about 20,200 kilometers, around 12,250 miles. These satellites are positioned so that at any given time, at least four of them are visible for any point on the Earth. At a time, four satellites can be visible. And the second point is signal transmission. Each GPS satellite continuously transmits signals that include the satellite's location and the exact time the signal was sent. Third point is signal reception. A GPS receiver, such as the one of your smartphone or ear, picks up signal from the multiple satellites. And third is the calculating distance. The receiver calculates the distance to each satellite based on the time it takes for the signals to travel from the satellite to the receiver. This is done using the common formula distance equal to speed of light into the delay, time delay. So this is a common formula which you are very known, well known. And the third is trilateralism. To determine your precise location, latitude, longitude, and altitude. So the receiver uses a process called trilateration. By knowing this distance to at least 4 satellites and their position, the receiver can pinpoint its own location through the multi-mathematical calculations. So what are the main parts used in this GPS system to work? First is the satellites. First, the space segment of the GPS consists of the satellite which transmit the signal to receive on the Earth. Second is the ground control stations. Ground control stations monitor and manage the satellite network, ensuring the satellites are functioning correctly and their positions are accurately known. Third is a GPS receiver. GPS receiver has three main parts. One is the antenna, second is the receiver process, and third is the clock. So purpose of the antenna is to capture the signal from the satellite. Receiver processor the signal to calculate your location. And third is the clock. A precise internal clock helps meaning of the time delay of the signal accurately. And the fourth is the user interface. In consumer devices, the user interface such as the screen or app displays the calculations position of the users. So this is the about the GPS, how it works.
Okay, so what critical mistakes a GPS can make and how we can fix them?
GPS systems can sometimes make errors due to various factors. For example, main GPS mistakes are the first is the signal multipath. When your GPS signal can bounce off building, mountains, or other large surface before they before they reach the receiver, causing the signal take a longer path. So to rectifying this problem, use receiver with advanced multipath rejection algorithm and place the receiver in an open area away from the tall building or the reflective surface. And the second is the atmospheric delay. Sometimes GPS signals can be delayed as they travel through the Earth's ionosphere and the troposphere layer. So, to rectifying this problem, modern GPS receivers use models to correct for atmospheric delays. Additionally, different GPS can provide corrective by the using of network of the fixed ground-based reference stations. And third is the satellite geometry. Poor satellite geometry occurs when the satellites are clustered closely together in the sky, leading to a less accurate positioning. So, to rectify this problem, ensure the receiver has a clear view of the sky to assess a wide range of the satellite. Some receivers can also predict and mitigate poor geometry situation. Another is the clock errors. Some errors in the satellite or receiver clock can lead to the inaccuracy in position calculations. So, to rectify this problem, GPS system regularly synchronous with the highly accurate atomic clock. Using more satellite can help average out of these errors. And fifth is the empiric error. This type of error occurs when the information about the satellite position is incorrect or outdated. So, to rectify such problems, regular updates from the ground control situation ensures accurate satellite position data. Receiver that frequently update their satellite data can mitigate the error. And another is the international signal degradation. The international signal degradation of the GPS signal by the US government for the security region, which has been discontinued since. So, to rectify this problem, longer applicable solutions are available, but alternative navigation systems such as the GLONASS, Galios, and ViewDo can provide the redundantly. And another is a receiver noise. Electronics noise within the GPS receiver can cause an error. To rectify this problem, a high quality receiver with low noise design and components can reduce this error. Another error is the interference and jamming. In this case, external sources of the radio frequencies are deliberate. Jamming can disrupt GPS signals. So, to rectifying this problem, use GPS receiver with the anti-jamming and anti-interference capabilities in critical applications. Combining GPS with the other navigation systems such as the inertial navigation system can provide a robustness. So, in brief, you may say, we can say while GPS is generally reliable, it can be affected by the several types of the error mitigation strategies, including using the advanced receivers with the error correction algorithms, ensuring a clear view of the sky, updating satellite data frequency, and using the complementary system for the enhanced accuracy.
Okay, so what challenges might a GPS navigation system face?
Yeah, the few challenges that GPS navigation system fails is first one is the availability of the satellite, because the GPS work on the by fixing the the position using the multiple of satellites. So suppose that I have one satellite here, I have other satellite here, I have another satellite here. So using these satellite constellation, it will able to fix its position and find its position. So that is what we call the GPS fix. So one is the satellite availability in that area. So there should be GPS should must be fixed with two or more satellite to find the accurate location. The second challenge it faces is the power consumption, because it always need to be finding the satellite around itself, always need to be scanning the satellite around itself and get the position accordingly. So another is the power consumption. The third is the signal strength. So one challenge is the signal strength. Like if you deploy some GPS based device in the very dense area, very populated area with lots of concrete building, then the satellite interference with satellite signals might be not reachable in very dense and highly populated area, and its accuracy might be sometimes decreases, and sometimes even don't even work. So like if you're using the drone, if you have used the drone, then if you put the drone GPS based drone inside the room, and if you want to turn it out, it will not turn. It will not fly, not turn on, because the GPS on the drone is not fixed. It needs an open space to get fixed with satellite able to scan the satellite. So these challenges happens with with the GPS based system. And second challenge is the jamming challenge. Like suppose that if you have an autonomous robot that uses the GPS to navigate and go to the certain area, then anyone can divert the robot by jamming or scooping. Another problem is the scooping. Anyone can scoop the GPS, or anyone can jam the GPS if they have the jammer devices. So this is another challenge that you might face. The third challenge is the is you might notice in the while navigation using the GPS on your phone, that you have a flyover and you have a road. So it will show you the path straight, but it don't show you whether you have to take the flyover or to take the road, because both have the same path. So in such a navigation system, it GPS fails. But while there are we have the NAVIC Indian made, they have these functionality where it can tell you the whether you need to take the flyover or the path under tunnel. And second challenge is GPS might fail in the tunnel or closed space, like I've told you, because the satellite signal might be not might not reach in those tunnels. So if you have any autonomous driving, or if you're using the GPS navigation in the tunnel, then you might face the the problem with GPS device. So these are the few problems that you face with the GPS.
Okay. So what is the difference between normal GPS and differential GPS? And can we say that differential GPS is better than the normal GPS?
Yeah. The differential GPS are better because it enhances the accuracy, and in the error caused by the atmospheric conditions, the satellite clock inaccuracy, or orbital error, and in all those error that you might see in the GPS based navigation system, you will not you will find the DGPS a better choice in such cases, because it reduces those error caused by the satellite clock inaccuracies or the atmospheric conditions, and it give you the improved position accuracy as well. And the better it will also perform the better than the GPS. So if you want to use the GPS based system, you use the navigation based system where the accuracy matters to the centimeter level, or if you are using the GPS based agricultural drone, if you are using it in the aviation technology, if you are using it in the mapping system, if you are using in the marine navigation, then in such areas the DGPS is better choice than the GPS, because it's reduces the error, it's enhance the accuracy, and in those areas it will perform better than the GPS.
Um, how do receivers that use more than one satellite system work better than those who use only one satellite?
Receivers that use systems often refer to a multi-GNS global navigation satellite system. Receivers work better than those using only one system due to the several advantages. There are various advantages of the multi-GNSS receiver, such as increased number of satellites. Using a multiple GNSS, for example, GPS, GLO, NASS, due means more satellites are available for positioning. What are the benefits of using increased number of satellites? There are various benefits. It improves the accuracy and the reliability as the receiver can calculate positions using more satellites, reducing the effects of the poor satellite geometry and the providing better coverage. And the second is the improved accuracy. More satellite provides more data point for the receiver to calculate a precise locations. So what is the use of the what is the benefits of the improved accuracy? It enhanced accuracy through the better trilateration and the error averaging, leading to more precise positioning. Another point is the better signal availability in challenging environment. When you are using more satellites in urban areas, dense forest or area with the significant obstructions, signals from one system might be blocked or reflected. So what are the benefits? Multi-GNSS receiver can use signal from the multiple places And the next point is the enhanced resilience for the errors interference. Different GNSS considerations have varying signals, structures, and the frequencies. There are very benefits. There are more benefits using such type of the errors. Using multiple systems can mitigate errors and interference that might affect one system but not others, leading to more robust performance. Another is increased redundancy and the reliability. Relying on multiple systems provides a fallback. If one system experiences issue or outage, so what are the benefits? It ensures continuous operation and the reliability crucial for the critical applications like aviation, maritime, and the emergency services. In brief, we may say that the multi-GNSS receiver leverages the strength of multiple satellite systems to offer superior accuracy, reliability, and the performance compared to the single system receiver. So they achieve this through increased satellite availability, better coverage in challenging environment, faster initial positioning, and the enhanced resilience to error and the interference.
Okay, so what are the GNSS augmentation and how do they make GPS work better?
GPS, actually, a global navigation satellite GNSS augment system enhances the performance and the reliability of GNSS signal, such as they form a global positioning system GSM. These augmentation system improves accuracy and the types of the GNSS. Various type of augmentation systems are available here. First is the satellite-based augmentation system, SBAS. For example, VAS, Wide Area Augmentation System, VAAS. In this system, US EGONOS, geostationary navigation or system. In Europe, MAM, SAS, multifunctional satellite augmentation system. In Japan and Gagan, GPS added geo augmentation navigation in India. What are the main functions of such type of augmentation? SBAS uses a network of the ground reference stations to monitor GNS signal. These stations send data to geostationary satellites, which broadcast correction signal to GNSS receiver. This enhances the accuracy and the integrity of the positioning of the information. The second augmentation is the ground-based augmentation system, GBAS. Example, LAAS, local area augmentation system. What is the function of LAAS? GBS provides differential corrections and integrity monitoring for GNSS signal with a localized area, such as an airport. It uses ground-based transmitters to broadcast these corrections to improve the accuracy. And third augmentation is a network-based augmentation system. Example, CORS, continuously operating reference system network. What is the function of this CORS? These systems use a network of the fixed GNSS receivers to provide a high accuracy correction over a larger area. The correction can be assessed via the internet or other communication network. Now the question arises, how GNS augmentation system improve GPS. So first is the accuracy. Augmentation system correct the errors caused by the atmospheric condition, satellite orbit deviation, and clock discrepancies. The significantly improves the position accuracy of GNSS receiver, often bringing it down to a few centimeter or even millimeter in some cases. So after using augmentations, the accuracy improves. And third is the integrity. Integrity refers to the trustworthiness of the position information. Augmentation system provide real-time error detection and alert user when GNSS signal is unreliable. This is the crucial for the safety critical applications like aviation and the maritime navigation. Third is the availability. Augmentation system enhances the availability of GNSS signal by providing additional source of the corrections data, ensuring that the accurate positional information is available even in challenging environment. And the next is the reliability. By continuous monitoring the signal and provide a real-time correction augmentation system. Increase the reliability of the positional information, making GNS suitable for a wider range of the application, including those requiring high precise and the robustness. So what are the main applications of this system? First is the in this aviation, it ensures safety and accurate landing approach. Third, maritime, enhancing navigational accuracy for the vessel. Third, providing high precision positioning for construction and mapping. In agriculture, enabling precise farming technologies. And another is a personal navigation. It improving the performance of navigation system in vehicle or handheld devices. In brief, GNS augmentation systems are essential for improving the performance of the GNS as by enhancing accuracy, integrity, availability, and the reliability, thus expanding the range of the application and ensuring the dependability of the GNSS signal.
Okay, so what actual problems can occur with the GPS signal and how can we resolve them? Ashwini, you have to unmute your mic.
Okay. So there are lots of problem happen when you use the GPS based navigation system and because of the signal. So as I have already told you that its signal became weak and sometimes even not available in the indoor environment, in the dense environment. So suppose that if you want to use a GPS based system, GPS based device in the dense forest where the forest is covered by the tree, then the signal reaching of the signal is very difficult and sometimes you lost the signal. And when you use the GPS inside the tunnel, inside the road, you are navigating using the GPS, then in the tunnel they toss the signal with the satellite and they give you the inaccurate data and the position. And second and then another problem is the dense environment, populated area, and a lot of signal interference with the other devices. So these cause the lots of problem with the GPS navigation. Now let's talk about how we tackle these problem, how we tackle these situations that we face in the GPS based system as a design engineer. So there are various ways by which you can enhance the GPS based system more accurate. So few of them are very common, like having the good antenna, having the better antenna or multiple antenna, and using the better better reliable good GPS chips. But apart from these, in the design you can also add the accelerometer or magnetometer in the design. So if I add the accelerometer and magnetometer, then there is a system that is called dead reckoning. So what the dead reckoning is, see, suppose that I have a GPS device, my vehicle is running with a certain speed, and now I enter in the tunnel, the GPS signal is lost because it can't reach in the inside the tunnel. So now what this dead reckoning system will do, they have the magnetometer, they have the accelerometer. So at what speed my vehicle is running, it will calculate using data speed, it will calculate the accurate position using the previous position. So suppose that my speed is 1 kilometer, and before entering into the tunnel and losing my GPS based signal, its latitude is certain degree, 135 or 35 degree north or south latitude, longitude. So it calculates the distance and time and the speed, and it will able to predict that your current position should be this, because your speed was this before the losing, and now you are running at this speed, your vehicle is going at this speed, so your current position will be this. Now using the magnetometer, using the accelerometer, it will get the acceleration, the velocity at which my vehicle is going before losing my signal, and it will able to tell the longitudinal data that at this position my vehicle is might be because of that speed. But what if I go in the reverse direction with the same speed, then my position remains the same, and it is telling that you have gone from that position to the forward. So in such case scenario, this accelerometer combined with the magnetometer, so now the magnetometer will get the direction at which you are moving the vehicle. So now it will accurately tells you, even with in the tunnel, accurately tells you that your current position in this. So you might have noticed that you are using the phone for the navigation, or if you have any kind of navigation system on the car, and you enter in the tunnel but still showing you the correct position. But what's happening there, your car have lost the connection with the satellite, because it can't enter into the tunnel, but it still able to give you the accurate data and about your position, because using the magnetometer and accelerometer, it calculates what your position should be and in which direction you are moving and at what speed you are moving, and it calculates the accurate location using the last endpoint. So these are the few things that you can add with the GPS system to make it more accurate, and you can tackle these challenges that is faced by the GPS thing.
Okay, so we have discussed about multiple navigation systems like GPS, GNSS, NAVIC. So how does the integration of multiple navigation system improve the overall positioning and accuracy and reliability of a system?
Yeah, so suppose that if you want to add few more accuracy, and you don't want to totally depend on this dead reckoning algorithm, and don't want to totally depend on these kind of accelerometer or magnetometer based data prediction and getting the location, like some approx location using that. So you can add multiple of the different systems as well. Like with the GPS, you also include the NAVIC. With the GPS, you also include the some another GPS technology like Baidu and Galileo, or other whatever so it's said. Or you can also use the GNS and NS based system or cellular networks based system. So by adding these, you are not only reliable on this GPS, but you have a backup plan for if suppose that one device fail, one GPS navigation fail, then I have the NAVIC. So if my GPS will fail in certain situation, then at the NAVIC in India, it's work better, because we have our own Indian satellites around our own land, and so it will work better and will give you good signal strength than the GPS. So we have a backup as well. So using these both data, we can give the more accurate data regarding the position and the navigation. So like suppose that you have the GPS and NAVIC as well. Now you are running on the road, and suppose that a tunnel, like I've just told you that one of the problem that is faced by the GPS is the tunnel and the flyover. So GPS will give showing you have to go to the straight, but in the straight you have a road and then the flyover. So whom to take, the flyover or the road? It didn't take you, but the NAVIC can tell you. So adding both the things, it will make you more reliable and more accurate data, that whether you need to take the flyover for the for certain path, or whether to take the underground roadways. So these things, by combining this thing, you can give you more accuracy, and it will give you more reliable data.
Okay, okay, interesting. So, what are the security concerns associated with navigation system, and what measures can be taken to protect against spoofing and jamming?
Security concerns associated with the navigation systems are: first is the spoofing. Spoofing involves sending the fake GPS signals to deceive a receiver into a calculating incorrect position, velocity, and the time information. So, what is the impact when spoofing is taking place? It can cause a navigational system in misguide users, leading a potential accidents or the malicious routing. And second one is the jamming. Jamming occurs when a stronger signal overwhelms the legitimate GPS signals, causing the receiver to lose its availability to calculate accuracy positioning. And third is the cyber attack. In these involve hacking into the navigation system, software, or network. So, what is the impact of this cyber attack? Unauthorized access or manipulations can compromise data integrity and the system functionality. Third is the signal interference. Signal interference on international interference from the other electronics device or the signal. So it impacts, degrade the quality and the accuracy of the GPS signal. Another is physical attack, tampering with the hardware components of the navigation system. So it impacts direct damage or manipulation of the navigation equipment can lead a system failure. So now come on the measures. Measures to protect against the spoofing and the jammer are the first authentication. Authentication implements the cryptographic technique to verify the authentication of the GPS signal. And example, what are the example of the authentication? Use a encrypted military GPS signal, for example, M code in the US military GPS. Second is the anti-jamming technique. When you are using the anti-jamming technique, it deployed. So, example of such type of anti-jamming technologies, it adapts antenna and the null steering, which can focus on time signal and the ignore jammers. Another is the signal integrity monitoring. Continuously monitor signal integrity to detect the anomalies. Example, receiver autonomous integrity monitoring, RAIM, used in this aviation. Which is the multi-constellation receiver. Use receivers that can process signal from the multiple GNSS, global navigation satellite system constellations. Example, GPS, GLONASS, Galileo, and others. These increases the resilience against spoofing and the jamming. Another is a redundant system, implants backup system to provide navigation capabilities if primary system fails. For example, inertial navigation system INS that do not relay an external link. Another is the software update and the patching. Regularly update software to protect against the known vulnerabilities. Example, it implementing security patches and the upgrades to navigation system software. Another is the regulations and the standard. Establishes the enforcement standard for the navigation system security. For example, International Civil Aviation Organization ICAO standard for the aviation GPS. Another is the education and training. It is very important. It trains operators to users on recognizing and responding to spoofing and the jamming incident. For example, regular drills and the simulation for the critical infrastructure personnel. By implementing the above, which I explained, so these measures, security can be maintained.
Okay, so how do advancement in machine learning and artificial intelligence make the navigation system more improved navigation system?
Advanced in machine learning and AI and their contribution to the navigation systems are it first enhance the route optimization. Machine learning algorithm analyze vast amount of the traffic data, weather condition, and the historical pattern to optimize the routes. It impacts provide more efficient time saving routes and the reduce fuel consumption and the travel time. Another is real-time traffic prediction. Using this AI and machine learning, real-time traffic prediction can be done. AI models predict traffic uh, and by analyzing real-time data from various sources such as sensors, cameras, and the user devices. So it helps in proactive route adjustment, avoiding traffic, jams, and improving overall travel experiences. Third is the improved accuracy. By using these machine learning and AI, AI machine learning enhances the accuracy of GPS by correcting signal error and integrating data from the multiple sources. So it provides precise location information which is critical for the application like autonomous vehicle and the drone navigation. Next one is the autonomous navigation. AI-powered systems enable autonomous vehicle and drone to navigate without human intervention by processing sensors, data, maps, and the real-time informations. Another is the predictive maintenance. Machine learning algorithm predicts potential failure in the navigation system by analyzing using pattern in the sensors data. It reduces downtime and the maintenance cost by enabling timely intervening before failure occurs. Another is the anomaly and the detection and security. AI system detects the anomalies and the potential threats such as the spooking and jamming by continuously monitoring signal integrity and the behavior of the pattern. It enhances the security and the reliability of the navigation system, protecting against malicious attack. Another is the context-aware navigation. AI system provides context-aware navigation by understanding under the preferences. So it hybrids. It impacts
Uh, you are on mute. Suresh sir, you have to unmute yourself.
another is the integration with the IoT. Machine learning and AI integration navigation system with the Internet of the Things IoT align the seamless communication between the vehicle infrastructure and the device. It impacts the of smart by the initiative, connected vehicles ecosystem and the efficient traffic management. Another is NLP, natural language processing. NLP technology enable user to interact with the navigation system through voice command and the natural language queries. It improves user experience by making a navigation system more accessible and easier to use. And the last one is the crowdsourced data utilization. AI algorithm process crowdsourced data from the millions of the user insights, map accuracy, detect fault condition, and identify point of the interest. It continuously improves the quality and the relevance of the navigation data, keeping all users. These are the main points which I have explained about this one. AI and the machine learning.
Okay, so, is there any other emerging technology that can replace GPS?
Yeah, now as the problem with the GPS, design engineers have faced with those signal things, scoping thing, jamming thing. So because of these problems, now design engineers are now working on many various technology that can enhance the GPS accuracy or either work without the GPS or better technology than the GPS. So one of the technology that is recently developed by the Nordic Semiconductor, that is the SSID based location system, and I have also personally made one design on that project. So what it do is SSID based location system. It will scan the networks of Wi-Fi around it, and using that network SSID MAC address, and using the RSSI between the routers and your device, the GPS device, sorry, that navigation device, it will accurately give you the better data than the GPS and a more accurate data than the GPS, and it will locate you. So these kind of navigation system might replace the GPS in the future for that, because if you use the GPS in the indoor environment, it fails. In the inside the tunnel, it fails. In the very dense populated with the tower, with a lot of tower height building, it suffers. So in such a condition, if we use the Wi-Fi based system or the cellular based system, or the BLE beacon based system, so the design engineers are using these alternative system to make a better GPS technology, and that can replace the GPS, like one I have to told you, the SSID based system. And second one is the BLE beacon based system or the Wi-Fi based system. So like now the cities, you can see the cities are getting, in the cities lots of people have the phone that have the Wi-Fi hotspot, and most of the smart cities have the Wi-Fi hotspot or free Wi-Fi area, network area at the street to help the people out. And most of the offices have the Wi-Fi, so everywhere there is a Wi-Fi network. So we can use these Wi-Fi network to get the more accurate data than the GPS, where the GPS even suffers and where the GPS even can't work, and it will give you more accurate data in the indoor environment as well. And you might have seen, also have noticed that in the train application, you might have the train application, so you will get the accurate train data, that at what location train had reached, at what speed the train is now going. You might have noticed and used these kind of application while traveling with the train, that it is giving you those application will give you the real time data of the train and the exact location of the train at what location. Even if that railway department didn't sharing those data, GPS data of the train with those application, but these applications are giving you the accurate data regarding the train speed and regarding the train current position. So how do they do this? So they are using these technology. They are using these Wi-Fi, these phone networks of different phones. So all there are more than 100 passengers in the train might have using the same application, and using those application, they will able to use the Wi-Fi networks. They were able to use the cellular change, and they will able to calculate the accurate position of the train without even getting the GPS data from the railway. So these are the SSID based location system, BLE beacon based location system, or the mobile network based location system. These are the few emerging technology that might replace the GPS thing for the many of the applications.
Okay, so you talked about SSID based location system. So how does a Wi-Fi can find where a device is, and how accurate the system is, how well it works?
So as the Wi-Fi based accuracy system, I have told you that in the satellite based system, they have to take signal from the sky, the satellite. So you need the open area, you need an open space. So if the space is closed, the dense, if you are in the indoor environment, those signals might not reach you. But in the Wi-Fi scenario, it's the different. So you have the Wi-Fi in the room, you have the Wi-Fi in your phone, you have the Wi-Fi in the neighborhood, you have the Wi-Fi in the office, you have the Wi-Fi in the street, you have the Wi-Fi in the railway station, we have the Wi-Fi, they're everywhere Wi-Fi. So now we have a lot of these Wi-Fi signal, and we have a lot of cellular signal as well in these areas. We are getting the cellular network in all those areas and the Wi-Fi signal as well. So if we combine both of these, then we can get the accurate data using those technologies. So how these work? So suppose that I am currently in this location, and I have my phone hotspot Wi-Fi, and nearby people are also using the phone hotspot and have the Wi-Fi, and then my GPS will be on, and the nearby office also have the Wi-Fi, and the street also have the Wi-Fi, and the office also have. We have a lots of different Wi-Fi hotspot out there around me, and Wi-Fi signal out there around me. Now what my device will do, it will scan the network, and then it will find that all those different routers and their current locations, using their SSID. Now using the triangular technology and using the algorithm, it will able to calculate that my phone signal strength from that Wi-Fi router is this, and the signal strength from this Wi-Fi router is this, and signal strength from this Wi-Fi router is this. So my location might be this because I am little bit closer. My signal strength is little bit more stronger to this Wi-Fi network, so I might be at this position. So it will scan all the area, and it will able to calculate the different signal strength and find the exact location where I am. And even if I move a certain amount of certain centimeter away, so the RSSI, the signal strength between all those different router will be change, and it will able to calculate at what direction and at what speed I am moving, even in the 1 centimeter level. So this is how accurate it can be. So this is how this whole system can work, and if in the future this can be replaced by the GPS.
Okay, so I'm coming to my last question. So how can we make GPS more reliable and accurate even in challenging situations?
So even in the challenging situation, if you want to make a GPS more reliable and more accurate, you have to always need to add with some other technologies, and you have to always add, like I've said you, that suppose that GPS fails in the denser environment, in the indoor environment, then you can add that GPS with the BMP sensor, barometric pressure sensor. You can add the GPS with the Wi-Fi SSID based navigation system. So now if the GPS fail, if the GPS signal sometimes suffers, then what it will use the backup, the SSID based location system to scan the network and get the position. And by combining with the GPS data and the SSID based location data, it will able to find more accurate and give you more centimeter level of accuracy data using that. And suppose that if you are using the GPS, but the GPS can't tell you that at what floor you are, at what height you are. GPS can't tell you, because it can only tell you the current latitude and longitude. It's a longitudinal data. It's the two-dimensional data. It's either this axis and this axis. So there are two satellites, and using those satellite signal, it will able to find you are at this axis from Z and X and Y. It's two-dimensional data. It's not the 3D. It is only giving you the latitude and longitude. But what about the height? What about altitude? What altitude you are? So if you add the and if you and there are certain things where you need the altitude data as well, at which floor in the room you are, at which floor it is, at what height that my drone is running. So if you want to find the height as well, then GPS will not give you going to give you this data. It is only going to give you latitude and latitude, not going with the altitude data. So if you for getting the altitude data, the height, you can get it by the BMP sensor, the barometric pressure sensor. So there are lots of barometric pressure sensors out there in the market, from the Bosch BMP 280, BMP BME 280, and there are few another barometric pressure sensor from the Maximum Integrated, ST Microtronics, and there are lots out there in the market. So what is the barometric pressure sensor? It will sense the pressure change at the different height, because when you go at the different height, air pressure change at different level. So using that air pressure level, it will able to accurately tell you that what height you are. So it will able to give you the height data as well. So now GPS is only giving the latitude and longitude. Now it will also telling you at what height you are, not only the position, but at what height you are. Now if you also need few more data, few more accurate data to it, so then you can add the magnetometer and accelerometer. Now GPS is not only telling you at what height you are, not only giving you that device not only giving you the at what latitude and longitude you are, it will also giving you the data regarding your speed using the accelerometer and the tilt level. Suppose that my drone is this, and it's moved to the 30-degree towards the azimuth. So there is another dimension, it is giving you the azimuth level, the tilt level, at what amount that you are tilt, that drone is tilt, or I am falling, or whatever the thing. It is giving another data about the angle, at what angle that is moving, using the accelerometer. Now if you add the magnetometer to the same things, to the same GPS device, now what it will get, it will able to calculate the magnetic field around itself, and we are able to get you the accurate magnetic heading, at what angle, at what degree you are in the directional data. So previously you were just getting the latitude and longitude data, the two-dimensional data, then you add the BMP sensor, then you get the altitude data as well, the height level as well, then you add the accelerometer, that will give you the tilt data, the angle data, and then you add the magnetometer, that you get the directional data, at what direction. So you are getting more accurate data about a device, about a drone, at what angle, at what speed, at what level it is in. So by adding these different technology to the GPS device, you can get more accurate data, more dimensions in the positioning system and then the navigation system. So that's thing we are going, we can add.
Okay, very good. So, thank you for your time, everyone, and thanks Ashwini and Sureshi for sharing such insightful information with us. And I hope the session was very informative for our viewers. If you have any doubts and questions, kindly post them in the comment section. We will get back to them in our next session. Thank you.
Thank you everyone.